Welcome to a brief introduction to Python. In this video, I'll be going over the history of the Python language. We'll discuss the features that make Python a great language, and we'll discuss in more detail the standout features of Python. Then we'll move on to a code demo where I'll be solving an exercise of the Python track, and we'll then list the resources that you can use to learn Python. I hope you're excited about learning Python, so let's get started. Python was conceived and developed by Guido van Rossum in the late 1980s as a successor to the ABC programming language. Its first release was in 1991, and it was developed in the Netherlands at the government-funded research institute Centrum voor Wiskunde en Informatie, CWI, which, by the way, is famous for the place where Eske Dijkstra did a lot of his work. Guido at the time was programming in both C and shell scripts a lot, and he sort of disliked both. He liked that C was a general purpose language and he could do a ton of stuff with it. And he liked the flexibility of a shell script and it being interpreted. But the downsides were big, and he thought that, well, maybe I can build a new language that didn't have the downsides of these languages, but did have the strengths of both. And that language became Python. Python is a dynamic and strongly typed language. It supports multiple paradigms, so there are different ways in which you can program in Python. You can program in an imperative or procedural way. You can use functional programming. But mostly Python is an object-oriented language, which is evidenced by the fact that literally everything is an object in Python. It is a true general-purpose language, which means that you can use Python for almost anything, like websites, scripts, or scientific computing. The Python language is managed by the Python Software Foundation, and interestingly enough, language changes happen via a process that's called Python Enhancement Proposals, PEPs, which are something like akin to RFCs. So it's a formal process where language changes are introduced first via proposals and then later on implemented. Let's go into the reasons why Python is a great language. First of all, Python has very pleasant syntax. Unlike most major languages, Python is whitespace sensitive, and this means that the indentation of a line determines its scope. So if you define a function, its body will always be indented more related to the indentation of the actual function. This means that code becomes easier to read because there is more consistency, there's enforcement of the scoping rules, but it also means that you can visually see the scopes, which can be really convenient. Python also makes an effort to have human-readable keywords. For example, combining Boolean expressions is not done via ampersand, as in many other languages, but via an AND keyword, so AND spelled out. And in general, Python just has very pleasant syntax to work with. The second feature of Python that makes it a great language is it being very dynamic. Python being dynamic means that you can quickly get started with prototypes, you can try out new approaches, and when you combine this with the fact that Python has a REPL, which is a console-like environment where you can just run code and Python will evaluate it for you, you can see how Python is a great language to try out new things, to see what works, etc. This is also evidenced in the fact that you have a thing that's called Jupyter Notebooks, which was evolved from IPython. And Jupyter Notebooks give a web-based visual representation of code. So basically you can see it as mixing plotting tools with code evaluation tools with a bit of text. So you could have a notebook that explores some data and it will describe the data. Then you would have a bit of line of code analyzing the data. Then you might have a plot that shows the data. So data exploration via Jupyter Notebooks is an incredibly powerful feature. And it's not only Python specific, it supports other languages too. But Python is incredibly well supported on Jupyter Notebooks, and it's a very cool feature. Python has a very pragmatic type system. It mostly tries to get out of your way. Python supports duck typing, which means that if you call a method on an object, if that object's class defines that method, then it's fine. You don't have interfaces or a hierarchy to check. Duck typing is very lightweight and makes it really easy to work with different objects implementing the same method. Python also has gradual typing, where you can add type annotations in your code, which can be useful for IDEs, for example. And as mentioned before, in Python, everything is an object. And it's this core that is applied everywhere. So once you really internalize this, working with Python becomes incredibly easy. Python is also a very expressive language, which means that you can do a lot with very little code. There are a couple of language features that make this especially true. So for example, you have list comprehensions, and list comprehensions are a very concise syntax to create new lists. And many of the for loops that you would write can be rewritten to list comprehensions. Another feature that's sort of like list comprehension, but only it isn't, are generators. And generators also generate data, but they do it lazily. So you don't have the upfront cost of allocating a list. And this laziness means that you can work in theory with unending number of data. Python also has decorators, which are functions that wrap other functions. So you could add, for example, logging functionality in a very declarative way. You can reuse that functionality across different functions. Python interrupts really nicely with C code, which means that you can easily call C code from your Python code. You can also easily call R and Julia code from your Python code, and the other way around. So this means that code that was written in R and Julia and C can easily be used in your Python program, which is a very powerful feature. Python is also a great language to learn to program with. It has excellent syntax, it's pleasant and it's fun, it's consistent. There are a huge number of documents available to learn from, ranging from website to courses to books, and the community is absolutely huge. There is also a lot of guidance on how to write idiomatic Python code, which is called Pythonic. And Pythonic code is being described in various documents, and it contains a number of guidelines/rules. For example, explicit is better than implicit, and readability counts. And having these documents available makes it a lot easier to write Python code the proper way. And finally, many OSs come pre-installed with Python. So it's in many cases, Python will already be available on your system. So it's easy to get started with. You don't have to install much. Let's discuss Python's standout features. First of all, its number of available libraries. There is a vast wealth of libraries that are available to you when you are working with Python. So when you're writing a new Python project, I would highly recommend you checking out what was already being written, because the number of libraries available is just enormous. A second standard feature of Python is that it is the de facto language for doing artificial intelligence/machine learning. If you are interested in that domain or you are working in the domain, you'll find that Python is everywhere. So if you want to do machine learning or artificial intelligence, Python is a great language to use. The third and last standard feature is that Python can be used basically anywhere. It is a true general purpose language. You can use TensorFlow to do AI, NumPy to do scientific computing, Django to write websites. You can use Python to write scripts on your server. You can build embedded systems via MicroPython. You can interface with hardware, for example, on Raspberry Pis. You can even build games, as evidenced by EVE Online using Python. And Python even went to Mars. In short, you can basically use Python for whatever you like. Let's look at some Python code. I'll be solving the Raindrops exercise. And Raindrops is an exercise where you get past a number and you have to return a string according to some rules. The rules are if the number has 3 as a factor, you add pling to the result. For 5, you add plang. For 7, you add plong. And if it turns out neither of the factors are in the number, then you return a string version of the number. So some examples: 28 only has 7 as a factor, so it returns plong. 30 has 3 and 5 as factors, so it returns pling plang. And 34 doesn't have any of the factors, so it just returns the string 34. So let's look at our starting point. We have a single function called convert. It takes a single parameter number, and its current implementation just has pass, which is like a temporary placeholder. It's syntactically valid, but it doesn't really do anything. So if we run our tests, so we'll open the terminal, we'll do Python 3-m PyTest, which is the testing framework. Then we'll do Raindrops test.py, and we'll see that, well, everything fails. So that's good because we expected it to. The first thing that you might notice is that there aren't any curly braces, which are very common in many programming languages. Python has a thing that's called white space sensitivity. So this line defines the function convert, but the body of the function must be indented. So this, moving this to the left, is not valid. You can see we get a expected indented block error. So we need to indent it with 4 spaces. So now it's perfectly fine and we have indented code. And that works everywhere. So if we get to an if statement in a second, we will use the same rules. Okay, so the algorithm that we will be implementing is to slowly build up the sounds by checking the factors one by one. So we'll start off by defining sound is empty string. We don't need to specify any types because, well, Python is a dynamic language. So the first thing that we need to do is we need to check if the number has the factor 3. So we can do that via the percentage modulo operator. So if number percentage 3 equals 0, and then we do colon, and then we need to indent again. So everything that has to happen when the if statement is true has to be indented relative to the if statement. So then we'll say sound plus is pling. So this adds pling to the sound. Then we copy paste this for the 5 factor, pling plang plong. So very simple. Then at this point we need to determine what we need to check, because, well, if the sound is still an empty string, then apparently it doesn't have any of the factors and we need to return the string version of the number. So if sound is equal to the empty string, once again we do the indentation, then we return, and then how do we convert the number to a string? Well, we do that via str. So the string function pass in the number, and in the other case we can just return sound. So let's see if this passes our tests. And we have a working implementation. It's all very simple, just some repetitive if statements, but you can see a couple of things here. You can see clearly that we don't have curly braces, we use indentation, and you can see that Python code, the structure is very clear because of that white space scoping. Let's move on to some change that we can make to this. Another thing that you might notice is the lack of semicolons. By default, Python doesn't need semicolons to terminate statement because there's only one statement by default on a line. But if you want to have multiple, you can use the semicolon for that. But we don't need that, so just as an aside. Let's move on. I don't really like this duplication because there's basically the structure is the same 3 times, there are just different values. So let's see if we can somehow parameterize that. And for that we'll do drops is, and then we'll introduce a list with the square brackets, pling plang plong. So this is a list with a string of 3 values. And then we have factors, which is 3, 5, and 7. And then we need to have some way of iterating over those. In a C-like language, you would do for I is 0 and then I less than 3, etc. But that's not how Python works. So if you want to iterate over a number range, you use the range function. So we're going to say for I in range 0 to, well, what is it? So we can check the documentation here. Stop is exclusive. So we're going to say range 0 to 3. And then we're going to do if number modulo factors and then the ith factor. So the first one is index 0, second one 1, etc. So then we do sound plus is factors I. Sound drops I. Okay, so let's try and run this again. And we have failing tests. So why is this the case? Oh, we forgot And it's actually quite a simple solution because we forgot to add equals equals zeros. So run it again. And now we have a working version. We no longer have the duplication of the code, but there is still things that we can do to clean this up a bit. So we are currently iterating over the indexes, and then we are indexing into the list. But this is a very common scenario where you want to iterate over the values of something along with their index. So there is a built-in function to do that, and it's called enumerate, and we pass in factors, and what it will return are tuples. And tuples are, in this case, elements that contain two values. So we have index and we have factor. And this is called unpacking of a tuple. So a tuple is an object, and we are now unpacking its values into two variables. So we no longer have I, we have index, which is probably a bit better name. And instead of factors I, we can do factor. So what we now do is we iterate over the factors, and we also get its index. So let's see if this works, and it still all works. And this is already a lot nicer. Another thing that we can do is we can use the fact that Python has truthiness. So certain values that are not Booleans are interpreted as true or false. And the best way to illustrate this is by opening a terminal. So we're going to do Python 3, and then we have the Python terminal, which is a REPL. So we can just add code here. So we're going to say if empty string is empty string, which is a bit silly, but then print hi. So this will print hi. So you can see that empty string is empty string, but if we do if empty string, and then we'll do print okay, we'll see that nothing is printed. So the empty string does not evaluate to true, it evaluates to false. So we can use this in our code. Python has a thing, an if expression. So this is an if statement, but we can also return the result of an if expression. So I'm going to put this into a comment, and we're going to use the fact that the empty string is false. So return. We're going to return sound, if sound. So if it evaluates to true, else we're going to return string number. So this is exactly the same thing as here, except for the fact that we have sort of flipped around the code. So it would be if, that will be the exact same analogy. So we're using the fact that strings can also be interpreted as Boolean. So that's truthiness. So get rid of this, then we're going to run our tests, and it still all passes. So I think we've already made things a bit better. Now that we have seen how useful tuples are, let's use them in our code too. So instead of having this drops list be just strings, let's make it a list of tuples. So we're going to have tuples be the factor and then the sound. So 3, pling, 5, plang, and 7, plong. We can get rid of factors. We can not enumerate over factors, but over drops. And then here, what values we have is the first value is the factor, the second is the drop, and then instead of having to index into drops, we can do this, and this should all work. So it does. So just to reiterate, drops is now a list of tuples, and we unpack each value into the factor and the drop. So the factor and the drop, and then we can use it in our code. There's a couple of refactorings we can do. We can remove these parentheses, and we can also slightly change this. So what we can do is use truthiness again. So we use this here with if sound, but there's also a keyword called or, and that is right side will only be evaluated if the left side doesn't evaluate to true. So if we use this, it basically means return sound if it is truthy, and if it isn't, return this. So run this, and it still all works. So I'll some nice refactorings, I think. Our next refactoring is to replace this for loop with a list comprehension. List comprehensions are a short syntax to generate a new list. So we'll do square brackets, and we'll copy this bit into the list comprehension. We'll put the if condition after it without the semicolon, and then in the beginning we get the value that we return. So we're going to return the drop. This is not entirely the same thing that we had before, because this is now returning a list. So these are the sounds. So to actually, we can get rid of this sound, and we're going to need some way of converting the list of strings to a string. So the way that you do that in Python is you use join, and join is a method on a string. So we have to work on a string. In this case, we do the empty string because we want them to be joined without any spaces or anything like that. So we do empty string.join sounds, save it, and then run it, and it still all passes. And of course, we can inline this to have it be like this. Maybe get rid of this line too, and it still works. The only thing that I could perhaps maybe do is to increase readability, is to have the if statement on the next line. So we could even have it like this. It's whatever you prefer. I think this is fine. So the final thing that we can do is to, instead of using a list comprehension, which allocates a list, is to use a generator. And the join method takes a generator, and the generator is similar to a list comprehension in that it generates values, but it does that without generating an actual list. So if we move this here, maybe we do put it like this for now, and I'll explain it in a second. So we can see here that we now call join with basically whatever we had within the list comprehension. So move the if statement here, and this should still be the same thing. Only this is more efficient because the list comprehension allocated a list, whereas this generator expression, where we don't have any square brackets, will generate the values for you. So we can argue about readability, whether or not this is still readable. I have quite a high zoom level, so it might be better with less zoom level. But this is a very succinct way. And I think the only thing that we really need to do is to move this into a constant. So we're going to move this out of the body. We're just saying capital drops, which is the convention. Move it here and then run it again. So I think this is all fine. One final thing that we can do is we can even get rid of these square brackets, because this is still, this is not a list anymore, but it's a tuple, which you can also iterate over. So a tuple of 3 elements. And now we have a very nice solution that is very declarative, and it works really well, I think. Let's look at some resources that you can use to learn Python. First of all, you can learn Python on Exercism via the Python track. The Python track has over 135 exercises, and they range from a wide variety of topics, from string handling to numbers to basically anything you can think of. What's even better is that the Python track has a syllabus. And the syllabus is a dedicated learning mode where you can slowly build up your Python knowledge via small exercises. So you start out with the basics, then you move on to numbers or booleans, conditionals, etc., until you get at classes and sets. So I would highly recommend you doing these concept exercises, as they will give you a very firm basic understanding of the Python language. Another resource that you can use is the Python tutorial on the official Python website. So this is of course a tutorial, so you get a lot of goodness on the basics of Python. You get basically introduced to everything you need to know as a Python programmer, at least in the beginning. So you have if statements, you have comprehensions, you have data structures, etc. So this is an excellent resource to get introduced to all the various aspects of the Python language. There's also Think Python, which is a very nice way of that does basically the same thing as the Python tutorial. So you have a list of all the different concepts that you have in Python, and this goes into a much more detail. So I would highly recommend you trying out this resource too. And then as Python is an incredibly powerful and also a very pervasive language, there are a lot of courses that use Python to teach computer science. For example, there's this MIT course, Introduction to Computer Science and Programming in Python, all free, of course. There is the Harvard's course, Introduction to Programming with Python. So if you're new to programming, this is perfect for you, but it might also be perfect for you if you want to learn Python. The Google Python introduction course, which is actually something that they used internally too, but they've opened it to the whole world. There's Microsoft's Build Real-World Applications with Python, where you build apps with Python to help learn it. There's the Learn Python module on Kaggle that helps you learn Python, which prepares you for machine learning, for example, and AI. There's the Practical Python Programming course. It's based, a lot of stuff is on GitHub. And there's also Automate the Boring Stuff, which is a book. And this book is very practical, and where you have to build small applications, and you get the benefits of doing these small applications, and then that you have something working. But you can even view this online. So if you want to learn about reading and writing files, you can read that online without having to buy the book. But you can, of course. So this is a very practical way of learning Python. And then finally, there is this 6-hour series of videos that prepares you to ace your Python interview, but it's also a very neat way of learning about Python. So there's a ton of resources that you can use to learn Python, and you're basically spoiled for choice. And with that, we've reached the end of this video. I hope this introduction to Python has been useful to you and that you're now keen on trying out some Python code yourself. Hope to see you next time. Bye!